All right, so we're moving on to the next section of geometry where we're going to just look at our basic building blocks. Some of these are assumed and some of them we prove. But we've got undefined notions. Undefined notions is just a bad name for something we can't define from other geometry terms. Like I cannot define a point based on a triangle or anything else like that. Same with all of these. These should be all the examples. They're at least all the ones that I could find. So we cannot define them from other geometric terms. If you're confused about the term, so you could put geometric ideas or figures here. And then if you're confused about the term, undefined again just means not defined from this, but notions means idea. So basically just another way of saying basic idea. Basic idea is a way to think about it. All right, postulates, these are things that we prove or that we assume. Sorry, these are assumptions. These are another things we assume. We assume them to be true because no one can really find counterexamples ever. There probably are one use of inductive logic. Everybody who's measured anything can say, oh, if I put two measurements together, it makes sense that their measurements add together. So measure addition postulates like if I have two lengths. So let's see, I've got a length here. Oh, I've got a length here, let's call it AB. And I've got another length BC. These two lengths put together make a bigger length because they're next to each other. You're not going to find a counterexample for that, all right? So that's what that means, the measure addition postulates. Basically, we can assume it without having to worry about it. Theorems are things we prove to be true, though. Now, all right, so one thing we've proved to be true is triangle angle sum theorem. So if I've got a triangle, we are eventually going to prove that the angles add up to 180 degrees. Okay? 180 degrees. So that's the theorem we're going to prove. We use proofs to prove theorems, and we'll get to those. Now, converses. These are statements that reverse the cause and effect. Cause and effect. They're basically theorems that reverse the cause and effect. But what's an example? The converse of the triangle sum theorem. So we just talked about how the triangle adds up to 180 degrees. What if I had some figure, I don't know what it is, but I know that the angles add up to 180 degrees. So in this case, I know that the triangle gives me angles that add up to 180. Now I've got angles that equal 180. It's going to give me that it's a triangle. Because no other figure is going to have angles that add up to 180. Only a triangle. All right, does that make sense? All right, now, what about these last properties here? These are statements in geometry that we're basically taking from other math. I'm going to say algebra, though, because most of what we do, you've learned from algebra. So if I say the transitive property, or if I say reflexive property, reflexive is probably the most useful. And here's a quick example from algebra. Reflexive property, that's going to be something like, I have 3, but I know that 3 equals 3. And later we'll see AB is equal to AB, or the measure of angle A is equal to the measure of angle A. Things like that, reflexive property. All right, but we pull a lot of them from algebra, so I'm going to say algebra on that. Now, moving on, we got one more basic building block, and that is definitions. Let me move this down for you. All right, right up here on the second page of notes, definitions. These are how we define geometric figures. And the reason I put them on this list is because they're used in proofs a lot. For instance, if I use the definition of a triangle, I will have to say, yeah, the definition of a triangle is that it's a shape with 3 sides. Or the definition of an angle is 2 rays meeting at a common endpoint. And we'll have to memorize that, but we'll see that in a second. So you see, we got we got just the definition of them. Can be used in a proof in order to just make a very obvious step from one statement to another. We'll get to it though. It's all right if you don't understand why we're doing those. But they are mostly used to go between, hey, I have something like perpendicular lines. Let me move that down. I got something like perpendicular lines. If they're perpendicular, that means that they make a 90-degree angle. Or if they made a 90-degree angle, then I can say that they're perpendicular. That's what the definition does for you. It's just a way for me to go between something, a statement of fact, and a mathematical statement. All right, now, next video is undefined notion.